welcome back to this channel, and our topic for this time is projecting a 1-meter sea level rise using IFSAR-Digital terrain model data. Sea level rise usually is determined mainly by two methodologies. These methodologies are used by scientists in determining the global mean sea level rise. One method that they are using is by way of employing what we call tide gauges, or tide gauge, or tide sensor, and these devices or these sensors measure the changes in the tide, and also factoring in the tidal heights, and by computing the data coming from the scores of stations from all over the world, they were able to compute the mean sea level. But in addition to that, also coupled with the tidal gauge or sensor data, they also employ what we call a satellite altimeter, wherein a satellite or a source projects a radio wave towards the surface of the sea or the ocean, and it measures the intensity of the reflectance of the radio waves, and also the time it takes to bounce back to the receiver, and the time and the intensity of the reflectance of the radio waves determine the surface water height. So by using these two methodologies, scientists were able to average or at least compute the global mean sea level. And based on literatures, sea level is mainly caused by at least, or perhaps, three factors. One of the causes is of course thermal expansion of the seawater and the ocean due to rising temperature, because as we all know, as matter heats up or warms up, it expands, and that's one of the causes of rising sea level. And in addition to that, one of the causes also of sea level rise is the mass movement or mass transfer of seawater or water from the melting of ice caps in the northern and southern hemisphere, in the northern and south poles. So this melting of ice caps produces mass transfer of water, and in return it raises the level of seawater. And again, based on literature, the least contributor to sea level rise is the transfer of land water down to the ocean, which is mainly caused by pumping too much inland water and down to the seas and the oceans. So given these facts, it is somehow difficult to get sea level rise data. So as a workaround, I'll be teaching you how to project a 1-meter sea level rise using IFSAR data. First is we need to have a target area, which is this one as my sample. So it's important that our target area is a polygon for us to be able to split it using a line. Then second, we need to have, of course, DTM or digital terrain model. So in my sample, my target area is composed of 4 DTM tiles or mosaic. So first thing that we need to do, if that is your data, so you have to merge it first. So for us to merge, first we need to go to our menu toolbar in our QGIS, which is in this part, and let's go to processing and click toolbox. It would appear at the right hand portion of our QGIS window. So here in the toolbox, in the search bar, type in merge raster. Okay, merge raster, and then it would return the merge tool under the raster miscellaneous. So double click this one. Okay, so this is the dialog window for the merge tool. In the inputs layers, click the ellipses or the 3 dots, and then select your raster layer or your DTM. So in my case, I have 4 digital terrain models. So I click OK, and then scroll down, and then under the merge option, again click the ellipses, and then click save to file. Then for the file name, I'll type DTM underscore merge underscore. You could type the name of your target area, but for this one, I'll just type target area 1, and then I'll click save. So after inputting all the parameters, click run. The task is complete, and you can now close the merge dialog window. So you will notice that in your layers panel, the DTM merged raster file will appear, and for easy viewing, I'll just move this polygon on top of the raster data so that I'll see the boundary of my target area. So now the next step that we have to do is we have to extract a 1 meter contour line from the merged DTM file. So to do that, again go to the menu toolbar of QGIS and click raster, and click extraction, and click contour. And here in the contour dialog window, in the input layer, click this drop down list, and then make sure that you select the DTM merged raster file. For the band number, just leave it as it is. For the interval between contour lines, change this to 1 or 1 meter. And then for the attribute name, just complete the word elevation. Then scroll down, and in the contours, select or click the ellipsis, and then select save to file. For the file name, just type contour underscore 1 meter underscore target area 1. Click save, and then click run. Now that we have generated a 1 meter contour, we can now close this dialog window. So for us to easily see the contour lines, I'll just move this on top of the polygon. Okay. Next step that we have to do is we have to open the attribute table of this contour layer. So I'll do right click, and then click open attribute table, and then click select features using an expression. So here we have to input a formula for us to select the 1 meter contour lines. So first thing that we have to do is expand these fields and values, double click elevation, and then click equals, and click all unique, and then in the values type 1 and double click this attribute information. So then click select features using an expression, and it should select all the 1 meter contour lines. Okay, as we can see, the 1 meter contour lines are highlighted. So now the next step that we have to do is we have to go to the processing toolbox and type in split with lines and double click split with lines under the vector overlay. So this one. So double click. Okay. So here in this dialog window, for our input layer, the input layer stands for the file or the layer that we are going to cut or we are going to split. So in this case, we are going to select, click the drop down list, and then select target area. And then for the split layer, so this is the layer that will split our input layer. So we have to select, of course, contour 1 meter. And very important, don't forget, we have to check selected features only, so that this tool will only use the selected line that we have specified. And then in the ellipsis, click save to file, and then we are going to save the polygon features. Then for the file name, just type in C level rise 1 meter and click save, and then after that click run. So now it is done. Just close this dialog window, and then it should return a split features. Now we can deselect the selected 1 meter contour line. So just click the layer and then click this one to deselect. So next step that we have to do, very important, is that start considering the inundation of the 1 meter sea level rise. So in this case, we will be deleting the feature or the polygon that are outside the 1 meter contour line. So in this case, this is the these are the features that are outside the 1 meter contour line. So I'll highlight the layer, and then I'll click. So this is the area. As you notice, we can see a demarcation line. So that is the 1 meter contour line. So meaning these highlighted areas here have elevation higher than 1 meter. And in case if sea level will rise up to 1 meter, these areas will not be submerged or covered with seawater. So let's delete more features that are outside the bounds of the 1 meter contour line. So you can use the arrow keys in your keyboard, and to select multiple features, just hold the control key and then select. So in this area here, we also have this one. Now that we have highlighted all of the areas or the polygon features that are outside the 1 meter contour line, then we have to, of course, enable our toggle editing for us to be able to delete these features. So you can click this icon here, delete selected, or alternatively you can just press the delete key in your keyboard. So I'll press this one. Okay, and then of course save layer edits, so that the changes that you have done will be saved in the file. Okay, so now that we have deleted the features that are outside the 1 meter contour line, then the remaining polygon features, which starts from the coastline going up, we assume that these are the this will most likely be the inundation of sea level rise. Okay, so now for us to emphasize the sea level rise data that we have generated, I'll uncheck the other layers that are not really important in this study. Okay, so next step, final step, second to the last step, we have to of course add an attribute information in our attribute table for us to be able to know the specifics of this particular shapefile. So I'll open the attribute table, and then we have to add a new field. Just of course you have to enable toggle editing. So for this field, I'll type in height in terms of meters, so that the user will be able to know the information that this particular shapefile carries. Okay. So for the length, I'll just leave it as it is. For the type, since I'll be inputting 1, so that will be okay. So okay. The next step, I'm going to populate this column. So I'll click this drop down list and then select height, and then for the formula, apostrophe, and then 1, and then I'll close it with apostrophe, and then update all. So it should populate all the records in this column, or in the rows in this column. So I'll click save. So that way I'll be able to know the information that this particular polygon carries. Okay, so last step, we're going to change the symbology of this polygon shapefile for it to look like a sea level rise. So I'll just change the color to red. For us to identify this particular slow onset hazard easily. Okay, so this is the IFSAR generated using a contour, a 1 meter contour line sea level rise. So this particular data is just a workaround in absence of a scientifically projected sea level rise information. And of course, we have to conduct field validation for this one, because even if we consider the topography of our target area, of course there are certain factors that we have to consider. For example, man-made structures that might prevent the intrusion of sea water in case it rises to 1 meter. So, but in any case, this could serve as our shapefile when we conduct climate and disaster risk assessment factoring in sea level rise. So that's it. I hope you learned something. Stay tuned for more tips and tutorials.